This is an example problem using Snell's law on the critical angle to determine if a light ray is reflected or refracted. The question we're answering is, will the incident light ray reflect or refract, and at what angle? So I've got my incident angle here at the picture on the left, and I can see my two indices of refraction. On the bottom is 3.4, on the top 2.6. Here's my strategy. First thing I'm going to do is kind of a problem within a problem. I'm going to find the critical angle, and I'll use that to compare my current angle of 28 degrees to. If 28 degrees is greater than the critical angle, the ray is reflected, and it'll be reflected at the same angle, or 28 degrees. If 28 degrees is smaller than the critical angle, then the light is refracted. Use Snell's law to determine the angle of refraction. So let's get started. Step one is to find the critical angle. To find the critical angle, it's kind of a problem within the problem. So I'm not going to redraw my 28 degrees. Instead, I'm going to draw my original setup, but I'll have this kind of generic angle, which is the critical angle. I don't know what the angle is of this line. I just kind of drew it generically. And I know this, at the critical angle, the refracted ray is going to be 90 degrees. So I'll use Snell's law, n1 sine theta 1 equals n2 sine theta 2. And then I'll set it up as 3.4 sine theta critical equals 2.6 sine of 90 degrees. Because remember, on the other side of the boundary, the light is refracted at a 90-degree angle. That's where that 90 degrees comes from. When I do my math, I find the critical angle is going to be 49.88 degrees. 28 degrees is less than 49.88. Because of that, it means that the light ray is refracted on the other side of the boundary, and I'll have to use Snell's law to figure out the angle. So now I'm back at my original problem. I know n1 sine theta 1 equals n2 sine theta 2. Putting in my numbers, 3.4 times 28 degrees equals 2.6 times sine theta 2. Sine theta 2 is 37.9 degrees, which you can see I have already shown on the upper left-hand corner. And this makes sense, because as I go from, light is refracted and I go from a high index to a low index, the light is going to bend farther away from the normal. So the answer 37.9, it makes sense.